Thanks very much, Lockie, and thanks for the great introduction, Keels. Look, I might walk around a little bit, but as the introduction was, my name is Ben Edser, and I was 2016 Nuffield Scholar and had the excellent opportunity of being on the India GFP. My topic is renewable energy technologies in the broiler poultry industry, cost reduction and income diversification. I was supported by AgriFutures, who were RIRDC Meat Poultry, so a very big thank you to them, and a very big thank you to Nuffield as well for the incredible opportunity that the scholarship was. Before getting into my talk, I just wanted to take a little bit of a sideline here and just ask anyone if they can spot a car in that photo at all. If you can't, it's probably my fault because it's not a very good photo, but I'll highlight it in red for you. That's this is New York City 1900, and that's the only car in this photo. We fast forward to New York in 1913, and it's a little bit easier to see, but if you have a look at that white spot, that is the only horse and cart. I showed that example just to it's called disruption, and it can happen when a number of interrelated factors can come together. And traditional mode of transport, horse and cart, that was used for 1,000 years, in 13 years was completely disrupted and changed. I show this example just because I think this is a little bit where we're at the moment in our energy industry and how we have traditionally thought about energy generation, and I think we're at the cusp of big changes. So this is my family, my beautiful wife Stephanie there, and our baby daughter Ivy. I was going to say a funny joke there, but anyway. So on the return from the CSC, Ivy was Steph and I made beautiful Ivy through some special cuddles. So it really has been a tremendous journey for our family, and we've gone through a lot. It's been great. So my study topic, the focus is really on renewable energy technologies in the broiler industry. I discounted a few technologies along the way, and I ended up focusing in on anaerobic digestion and solar. And also through my travel, I saw some quite interesting things about around dead bird disposals. I was quite determined to not only travel, investigate these topics, but also work really hard at applying them from an Australian point of view, both from a feasibility, operationally, and technology point of view. So why? Look, 70% of poultry farms' costs fall into 4 key categories: labour, electricity, gas, and bedding. There are some things we can do about labour, but they're reasonably out of our on-farm operational control. So I really focused hard on electricity and gas, which are major cost inputs. The broiler farming model traditionally has looked at a gross payment, and the farmer is responsible for the individual operational costs. We've also, over the last 10 years, just seen significant increases that we've probably all felt in electricity and energy prices. Queensland, I saw a statistic the other day that's increased 136% in the last 10 years. There's been huge amounts of investment in renewable energy technologies, which has driven down the cost curve and the cost of these technologies. And also poultry farms are significant producers of waste, mainly being poultry manure, but also dead birds. So I'm aware that renewables and agriculture have been looked at previously, but what I was really interested to find out was, are they really operationally feasible now, today? And my findings are, yes, they are. Where did I go? What did I see? Visited 13 countries. Initially, the CSC took me to Northern Ireland. I did a little bit of personal travel there as well, around the UK, mainly looking at anaerobic digestion. We had the GFP, which saw me go to Singapore, India, Qatar, Turkey, France, and the US. And then personal travel US, Denmark, UK and China. Of a couple of really light bulb highlight moments or industry changing moments was really catching up with DVO in the US, Exergy in Denmark, and then I got to see the three largest solar panel manufacturers in China, all worth $1 billion each. So anaerobic digestion. Why do I like this, and what's grabbed this for me from a renewable energy form? One of the real things that I like and I find is incredible about this technology is its base load renewable power solution. We know a lot about solar and wind. Solar generates electricity when the sun's shining, and wind when the wind's blowing. Because of this biological process, you've got built-in biogas storage, which if you're creating electricity, you're running a combined heat and power unit. And you can also do direct injecting into the grid, which is a bit of what I saw in Europe. So I mean the definition's up there. I won't bore you with it, but this is an example as well of the plug flow technology that I saw in America with DVO. A less complex and convoluted way to think about it, as a work colleague described it to me once, was if you think about farting bugs, that's what AD is. The other large issue that was really part of the journey was initially travelling around the UK and speaking to some technology solutions in Australia, or solution providers in Australia, were that you could not use high quantities of poultry manure in an anaerobic digester. Numerous reasons for this, which I'll run through on the next slide. But it was really the journey originally in the UK. There was a lot of the feedback I was getting, coming home, studying further, and then going to the States and going to Exergy. And I caught up with the same plant that John saw, which you'll see in a minute. But these guys have worked out a solution. So you've got on the top there, you've got the USA model plug flow. It's an in-ground concrete digester. You've got the traditional European style, which is a continuous stir tank. They do call those plug flow sometimes, but and then I just thought I'd throw a slide in there. It doesn't have to be necessarily this huge commercial installation, but I mean we did see small AD plants in India, for example, where they were using the biogas primarily for cooking. So AD and poultry, the problems. Obviously, for consideration is what is the bedding material that is in the poultry house or the poultry shed. In Queensland we use a lot of pine shavings. The complexity of the carbon structure on the pine makes it difficult for the bacteria to break down, so that's a challenge. We need to be cautious and think about what sort of bedding material is in our poultry sheds. Poultry manure is very high in nitrogen. To be able to recirculate or work any sort of liquid recycling, there is too much nitrogen for the bugs and you're going to have a digester problem. Particularly if you're looking at large scale, or what is a restricting factor on your installation, which may be, like with many farming, it's water. We don't have surplus water. If we did, we may expand. So liquid recycling is a big item for consideration. However, very happy to be able to report that, look, there is a solution and there's a few different technology solution providers out there that are providing it. I'll just walk through a little bit more on this one. Just kind of what is the process, because not everyone, I guess, understands what it is. So at the top we've got the feedstock. In this case, this is an example from Exergy in Denmark. We've got the poultry manure that goes into our biogas or anaerobic digester plant. We have at the back end going through. Oh, sorry, I don't have a pointer. Why is it there? There we go. Poultry manure feedstock into biogas, and then what comes out is the digestate, which is in a liquid and solid form. You imagine what goes in must come out after it's had its retention time and gas generation. Then you've got the ability to have a separation unit, so you can have your liquid fraction down here, your solid fraction down here, which we'll talk about this, but this is a high nutrient fertiliser. But it's this here from a poultry manure and a large scale point of view, which is really interesting. These guys call it NICS treatment, but less technically speaking, it's not dissimilar from what John was reporting about blowing microbubbles and air bubbles up through the digestate, capturing the nitrogen and NH3 and then treating it with hydrochloric acid, and you get this ammonium sulfate, $400 a tonne, or $400 a 1,000 litres. This can then get recirculated through your plant. It's this factor out here, which is either, you've got two options, your biogas can go, a lot of what they're doing in Europe is this, upgrading or directly injecting into the grid. Otherwise, more traditionally, can go through a combined heat and power unit. Combined heat and power being you are getting a thermal energy off your unit, and you're also getting electricity. Very interestingly enough, that a traditional broiler operation, on the work and the analysis that I've been doing, will on a single batch policy will have about 3 times, or additional 2 farms quantity of electricity that you can generate off the waste produced on site. So it's pretty exciting stuff. Thermal wise, which is circulating the hot water which comes off your CHP, comes off at about 90 degrees. You can circulate that through your poultry houses at about, comes off at 90 degrees, and there's enough there to have approximately 100% offset. If we're looking down at the byproducts, I think this is also, in addition to having the security of the operation on farm to take control of your power costs and your gas costs and be able to project into the future. There is also the, I guess, the income generation or business opportunity associated with this, where you've got byproducts of your primary operation, which may be to offset power. You've got these high quality, high nutrient fertilisers. If you've got surplus power as well, part of the business case must be looking at grid connection, entering into an offtake with a third party, and you can sell that surplus power. So the guys in the States, this was from DVO, and they had lined up a deal for the solid digestate, and they were bagging it, calling it magic dirt, and supplying Walmart over there. So it's very interesting. Ammonium sulfate is just an example, but again, you've got a high nutrient, effectively an organic fertiliser, which is a byproduct of this system. Solar. I won't go into it in too much detail. However, I did take the opportunity to go back through China, and I had a factory tour of the 3 largest solar module manufacturers at the moment: Jinko, Trina, and Canadian. All worth about $1 billion. It's $3 billion between the 3 of them. So we've just seen significant investment in this space recently, and a huge reduction in solar module prices. So as I said at the start, we've got increased electricity, we've got plus decrease in solar costs. Have we got a feasible proposal? Just a little bit of graphs about what's been happening in terms of the cost of solar, and the graph on the bottom right tracks CPI and electricity pricing, and we can see the separation. And again, I'm sure we've all felt these things recently. Just a little bit about an energy use graph. The black line shows, or here we go, highlighter. Here we go. This part is this is energy consumption on a typical day on a poultry farm, and then you've got this yellow line showing solar, a solar installation, energy production. We can see that they don't track consistently altogether. So the question becomes, I'm not going to talk too much about storage, but storage and batteries, there's a lot of talk out there. I don't think they're feasible quite yet. However, 2, 3, 4, 5 years time, I think this is going to come into a solution here, which is not going to be to totally take farms off the grid, but we know that our power pricing is generally split up into peak and off-peak. So there's the ability for that peak power pricing that you're paying your premiums for, up until that 7 p.m, 9 p.m, depending on what tariff you're under. And the question becomes, is that where this is going to come in first to be able to get us through that expensive period and into our off-peak pricing of the evening? But then, if you do have an installation that is, and it will have times when it is generating power depending on the size of it, what do we do with this? And it all comes into the business case. It's a little bit complex, but it just shows you this is an energy use of a typical poultry farm over a 12-month period. There's 5.5 to 6 batches of birds per annum. We've got that increase, and then the drop off as the birds come out. So we're just focusing in things on this. This is a kind of a solar installation. That's a larger one. This is a smaller one. We can see there is still a disparity. We need to consider these times where there's surplus spill electricity generated from our installation, and there's obviously times when we're not going to be generating power or we're going to be consuming power that is well over and above the solar. I won't talk too much more about that, but just some other interesting things that I saw. This is so EcoDrum guys in the US. Sorry, drum's got two S there. But this is showing dead birds going in one end, some sort of bedding, bulking material, and enclosed vessel composting system that rotates, and 2-3 weeks later what comes out is basically a composted blood and bone mix. The drivers in America, a lot are around bird flu and stopping contractors running in and around between farms, and potentially reducing the risk of disease. But these are still a great solution and something that I think we can look at further here in Australia. So as I said, originally when I set out, I not only wanted to look at these things, but then I wanted to really try and apply them here from an Australian point of view. So I've started working with AEM Investment Group and having a look at some poultry farms around solar PV and AD. And look, I'm really happy to report that solar at some level, smaller scale, in terms of energy offset, but behind the meter, makes sense. Okay, so if you're not considering it or thinking about it, I think you should. And then the opportunity to do a further and greater installation and be able to get that grid connection and to be able to export and sell that surplus power with an offtake third party. Again, a diversified income stream opportunity. And then anaerobic digestion. A lot of what I saw was at scale, and some of the work that I've been looking at is like a 20,000 tonne, 1.5 megawatt engine, but also been doing a fair bit of analysis on trying to scale that back into what size can we bring that back. And the work at the moment is showing that down towards a 16 shed circa farm that we're starting to get solution at that level as well. So the waste produced on site is a significant energy producer, and there's the opportunity to make this business case really work where we can get a grid connection because we've got surplus energy. The other opportunity is to pool resources if you've got farms around you, things like that. Just a little bit about the Nuffield Journey. I guess when I set out, I was looking a lot at value-adding the waste, and my focus was on composting. And we were working on a composting business at the time. This is still a great high nutrient fertiliser, but you still get this benefit with that solid and liquid form digestator, as I explained earlier. There's just a huge middle opportunity for income or energy generation, I should say. So we started with the value adding from waste to compost, and then really focused in and worked hard on the renewable side of things. So findings, recommendations, I did ramble through a little bit about these before, but look, these plants and installations, the work that I've been doing, they are viable. They deserve some consideration. You've got surplus, plenty of energy and biogas over and above your own requirements. There's the ability to not only offset your electricity, but also the thermal and the gas, using the thermal energy to offset the gas requirement on farm. Started doing the work on scaling these back because poultry farms all aren't at these huge scales. So a little bit more to be done on that. However, I'm getting back towards, as I said, around that 16 shed farm size seems to be working. Solar's viable. If you haven't thought about it before, think about it again. The challenge, and when I did some of my initial travel over to the UK, and I caught up with some funding groups, the Foresight Group who've done the deal with the Clean Energy Finance Corporation, that one of the biggest challenges they saw about this industry here in Australia is the continual change of the goalposts of our political system. So I mean these are 20, 30 year plans. That's their lifespan, so we need to be able to look into the future. But the problem is we've got things like targets under the renewable legislation, which takes us to 2020, and then the legislation runs till 2030, but talking about large-scale generation certificate pricing at $80 an hour, dropping back to 40. It's very difficult to do your modelling and your budget with these huge market fluctuations. So some further long-term planning and support and certainty, I think, would be of great assistance. And look, there's some good solutions out there for bird mortalities too. So I think that's me done. Thanks very much.